Hi, this lesson is on the metric system and the units that we will be using in physics this year. First off, it's important to understand why we use standard units. Why go to the metric system? There was nothing wrong with the English system, or was there? And we're also going to be focusing on the various metric prefixes, as well as how do I convert, recalling and converting between the base units here in physics. So, first off, the metric system was agreed upon by the international community. It's also abbreviated SI, which stands for Système International. This is a standard language. It allows scientists in different countries to be able to use a standard language for the various measurements and units that we need without having to translate or convert. Okay, so I don't have to worry that 1 inch is 2.54 centimeters and convert between that system and the metric system. The metric system also has the advantage that it's based on powers or multiples of 10. Okay, so centigrams, centimeters, millimeters, kilometers, these are all powers of 10, which allows us to do math a lot easier than having to remember that a foot has 12 inches and a yard has 3 feet and a mile has lots and lots of feet associated with it. Okay, so the powers of 10 is another strength. Okay, scientists who specialize in standards occasionally update the standards associated with the metric system. The point of updating it is either to allow for greater precision in our measurements or to allow the unit to be duplicated more easily or more precisely in different parts of the world. So, for example, when the meter was first defined, it was defined as 1/10,000,000th of the distance from the equator to the North Pole. In 1984, it was updated to the distance that light travels in 1/299,792,458 seconds. Look at the difference in the number of significant digits between those two numbers. 1/10,000,000th is one significant digit. That's easy enough to measure, but it's not very precise. Whereas the update has 9 digits of significant digits. A lot more precision associated with that. It didn't change the meter per se, but it allowed it to be duplicated more precisely in different parts of the world. The 3 primary measurements that we're going to be working with this year are mass, time, and distance. Mass we will be measuring in kilograms. Pay attention to this one. I know we've used grams a lot in chemistry last year, but in physics, our objects are slightly more massive. They're bigger, so kilogram is the primary unit that we will be using, not grams. Seconds is what we measure time in, and meters is what we measure distance in. In fact, all of the units that we will be using, with the exception of kilograms, have no metric prefix. Okay, mass and kilograms is the only one with a prefix. Okay, so pay attention to this one. The other 4 units that make up the 7 base units of the SI are current, measured in amperes, count, measured in moles, temperature, which is measured in Kelvin, and light intensity, measured in candela. These are the 7 base units of the SI system. Okay, every single other unit that we will encounter is going to be some combination of these 7 base units. For the sophomore year, we're only going to be focusing on the first 4 measurements. Okay, mass, time, and distance we'll be focusing on a lot. Current we'll have encounter in the second half of the year. Mole and temperature, mole and Kelvin you encountered last year in chemistry, and we will use them again in junior year and senior year physics. And light intensity we actually don't use almost at all. So, let's look at the metric prefixes. Okay, as scientists, we use a scientific notation or a slightly different notation called engineering notation to express very big numbers or very small numbers without using lots of zeros. Okay, it makes for a lot easier communication. Everybody, all scientists understand a millimeter is 1,000th of a meter, and we know it's a very small measurement, as opposed to 10 to the minus 3 meters, or 0.001 meters. Okay, so it's a lot easier to use those prefixes than always using lots and lots of digits or even using scientific notation. So rather than using the exponential form, certain powers of 10 are assigned a prefix for allowing easier communication. The engineering notation only uses multiples of 3, okay, for the exponent. So 10 to the third is kilo, 10 to the sixth is mega. Okay, and that's illustrated here. These are the metric prefixes that I want you to memorize. Okay, I really want you to have these memorized for the year. Okay, so I have the giga, mega, kilo. These are 10 to the ninth, 10 to the sixth, 10 to the 3. Notice that these are all exponents in multiples of 3, so we use them in the engineering notation. So I can say 25 kilometers, okay, 167 megabytes, okay. On the smaller side, we have centi for 10 to the minus 2, milli for 10 to the minus 3, micro for 10 to the minus 6, and nano for 10 to the minus 9. With the exception of centi, these are also prefixes with exponents that are multiples of 3. Okay, so I do expect you to have these 7 metric prefixes memorized and use them fluently throughout the year. The reason I want you to, because it allows, these metric prefixes allow you to easily convert from the metric prefix to a number you could use for calculations. Okay, and you do that by simply replacing the prefix with the appropriate power of 10. So for example, I have 12.7 millimeters. Okay, the first M is the milli, the second M is meters, and what I do is I replace the milli with the appropriate power of 10. If you don't have it memorized, milli is 10 to the minus 3. So I take that 10 to the minus 3 and I replace that milli with the 10 to the minus 3. So on your calculator, you would then enter 12.7 times 10 to the minus 3. There's no need to move decimal points in this type of situation. Okay, to go from the base unit to a prefix unit, okay, I have to multiply the base unit by the appropriate power of 10, but change the sign. So example, if I have 6.145 seconds and I need to convert it for some reason into microseconds, okay, remember micro is times 10 to the minus 6. Okay, so if I want to convert it to micro, I have to put times 10 to the minus 6, but change the sign. Instead of minus, it's going to be plus 6. So 6.145 seconds becomes 6.145 times 10 to the 6 microseconds. There are a lot of microseconds in 1 second. Okay, so that's how we're going to be using metric prefixes, and the more fluent you get making these conversions, the better off you're going to be. Okay, a lot of times students will make mistakes on the test simply because they got the units wrong. Thank you.